So this is the first video on analytical geometry, and we're going to look at distance. Now, an overview of what we're going to do is we're going to look at the distance between 2 points, and then we're going to look at using the distance formula. Now, when we're given any 2 points on the x-axis, it's very easy to see the distance between the points because we can just go 1, 2, 3, 4, 5. So there's 5 units between the 2 points. So you can manually or just look at it and count the units between them. Now, another way, if we're given the coordinates, and this is actually the right way, I would say. We're given the coordinates and we're asked to find the length of AB. Now we can see that the y values are the same, so the only difference is the x values. So what we're going to do is we're going to take the value that is the biggest and subtract the smaller value to find the distance between these two. So I'm going to say that AB is equal to the x value of b, because b is the bigger one, minus the x value of a. And then we're going to say 8 minus 3, and then we have 5. All right, so this is then when we're on the x-axis. Now another example, and also a reason why I would say this is the better way, because it's like foolproof. What if you have a value that is in the negative and one value that is in the positive? And we are asked to find that distance, so find the length of CD. Now the one way we can say, okay, from minus 5 to 0 is 5 units, and then from 0 to 1 is another 1 unit. So together they will give us 6 units. Or we can just think about the method of taking the big value minus the small value. So I'm going to say that CD is equal to the big value, so 1, minus the small value. Now just be careful because that small value is a negative now, so we're just going to substitute in negative 5. Then we just work that out. So a minus and a minus becomes a plus, so it's 1 plus 5, and then that just gives us 6. Right. Then let's look at this example where we have 3 dots and or 3 coordinates. The one is A, 5 and 3, B is 5 and minus 2, and C is 1 and minus 2. And we're asked to find the length of AB and find the length of BC. So in this case, we can see that the x coordinates of AB is the same. And when they are the same, then we can basically just find the distance by focusing on the y values. So it's very important that the x values are the same to then find the distance, because then the only difference is the difference between the y values. So I'm going to say the length of AB is equal to the y value of A, because that's the bigger value, or the one on the top minus the one on the at the bottom, minus the y value of B. Okay, so then we get 3 minus negative 2, and that becomes 3 plus 2, and that is then just 5. All right, now to find the length of BC, we can see that in this case they both lie on minus 2 as the y values. So the only difference is in the x values. So I'm going to say that BC is equal to the x of B, x coordinate of B, minus the x coordinate of C. Then we have 5 minus 1, and that gives us 4. Okay, now what if we are asked the difference, or what is the length of AC? Now obviously there's nothing in that's the same, like we don't have the same x values or the same y values. So we're going to look at the next section how to do it when we have 2 points that are not lying, for example, parallel to the y-axis or parallel to the x-axis. Okay, now let's look at those same 3 points that we saw in an earlier example. We've got A, B, and C, and we are asked to find the length of AC. So one way we can do this, like if we have the same questions that we had earlier, where we had to find AB and we had to find BC, we can take the lengths, because AB, if it forms a line, this line will go parallel to the y-axis, and if CB should form a line, it will go parallel to the x-axis, meaning this actually forms a right angle triangle. So we can use Pythagoras and take the distance AB, take the distance CB, and then just substitute it into the Pythagoras theorem to find AC. But that is not generally the case. Generally, we don't have B, okay? And then we will need the distance formula. So what we're going to do now is we're going to look at how the distance formula was derived, okay? So I'm going to focus in on this, and I'm going to change these 2 points to 2 general points so that it will basically work for any case in general. Now, how this formula is derived is not something that you actually need to know in your exams, but if you do know, it will just basically give you some more understanding, because the distance formula in itself, you need to know that off by heart. And if you know where it comes from, it's just easier to remember. So for these 2 points, I'm going to construct a right angle triangle. And then we're going to look at this point over here. So this point over here, what will it be in terms of the coordinates of A and the coordinates of B? We know that this line that I've constructed here is parallel to the y-axis, meaning that the x values stays exactly the same. So this will have the same x value as A, and then also here it will lie in the same horizontal plane as B, so the y value will be the same as B. So that point over there will be the x of A, the x coordinate of A, the same one as A, and the same y coordinate as B. Okay, now let's look at the distance. What will the distance from A to this point be? Now remember that the x values are the same, so to find the distance, we're going to find the difference between the two y value. So we take the bigger y value, subtract the smaller y value. So we'll have y of A minus y of B. So this is going to be our distance of this line. And then what is the distance of this line? We take the x value of A minus the x value of B. So there we have that distance. Now we are going to use Pythagoras theorem. So now we're going to construct the third side of this right angle triangle and just use the formula for Pythagoras. And then this distance over here, I'm going to substitute for A, and this distance over here I'm going to substitute for B. So what this will give me is AB squared is equal to this distance over here squared plus this distance over here. And then if we take the square root of both sides, we have what we know as the distance formula. Now, just a note on the notation of that. Normally in the formula sheet also, it's given like this. So the D just represents the distance, but when we are looking for something specific, we can replace the D with the specific distance that we are looking for, and we can also notate it as 1 and 2 instead of A and B. Alright, so that is then our distance formula. Right, so now let's look at the question that we had earlier to find the length of AC. So first of all, let's write down the formula. AC is the square root of x of A minus x of C all squared plus the y of A minus y of C all squared, square root. Alright, now I would recommend or highly recommend that you do write the formula down before you actually just, or not just substitute it into the formula directly. One, because it is easier then, or it helps you to remember the formula for the future if you write it down every single time that you actually use it. And secondly, depending on how the mark allocation looks like in your exams or tests, sometimes you actually get a mark just for writing the formula as well. So now next we can substitute it in. So the x value of A is 5. So we've got 5 minus x value of C is 1 squared, and then plus the y value of A is 3 minus the y value of C is negative 2 squared. Now you can put it in the calculator just like this. Me personally, I just like to simplify things first a bit, just to reduce the number of typing I do. So 5 minus 1 is 4, and then 4 squared is 16, and then 3 minus and a minus becomes a plus, so 3 plus 2 is 5, and then 5 squared is 25. Okay, then we can put it in the calculator like that. Right, so we've got the square root of 16 plus 25, and that is the square root of 41. Now, depending on what the question says, they can say leave it in the simplest third form. If they don't say anything, then you'll have to put it in 2 decimal places, okay, because that's the standard we do. So that's going to be 6,40, but in this case, we can just write it as 6,4. Now, for example 3, it says given the coordinates d, 2 and 1, and e, 4 and 7, use the distance formula to calculate the length of DE. So I'm going to write down the distance formula. DE is equal to the square root of x of d minus x of e, all squared, plus y of d minus y of e squared. Now, for me personally, this is something you can decide if you want to do or not. What I do is I list my coordinates underneath each other. It just helps me to do it faster, and it's just a way that I think about it. Because as we previously did, we said, okay, I need to substitute in xd, and then I go and I look for xd. And then I need to substitute in xe, and then I go and look. And there is the chance of you, by accident, like putting in the x value of d first, but then putting the y value of e first. So what I do is, if I have them listed underneath each other, then I just tell myself, okay, for the first part, I'm just going to say 2 minus 4. And then for the second part, I'm just going to say 1 minus 7. And another thing to note is it doesn't matter which coordinate you substitute in first. But what does matter is if you do substitute in the x value for d first, you have to put in the y value for d also first. So we can say 4 minus 2 for this part, and 7 minus 1 for this part, if we want to. So we're just going to substitute that in. So I'm just going to say 2 minus 4, so 2 minus 4 squared plus 1 minus 7 squared. Okay, and then we have negative 2 squared gives me a positive 4, and 1 minus 7 is negative 6, and a negative 6 squared gives me 36. Okay, and then let's put that onto the calculator. So this is 2 square root of 10. And then just to put it in decimal places is 6,32. And we're done. Alright, and this is just one final example. Determine the distance between the points F and G. So FG is equal to the square root of xf minus xg, all squared, plus the y of f minus y of g, all squared. Okay, and then I'm just going to list these two, 2 and minus 1, and negative 3 and 5. Okay, so when I substitute it in, I'm simply going to say 2 minus negative 3 plus negative 1 minus 5. And then we simplify. 2 plus 3 is 5. 5 squared is 25. And minus 1 minus another 5 is negative 6. So this is 36. The square root of that. And then we have 25 plus 36 is the square root of 61. And then just to put it in 2 decimal places, we've got 7,81. And then we're done. So this was the distance formula, and then we're done with this lesson.